Hey everyone, I wanted to take a look at this next question here. Heart rate while watching a romantic film. I think it's a little bit of a funny way to start up a question. It says the graph to the right shows the heart rate of a person watching a short romantic film, where X represents time in minutes and Y represents heart rate in beats per minute. Answer the following questions. And part A wants to know for which time periods was the person's heart rate increasing. So it looks like here from 1 through 4 minutes, and then from 9 through 13. Yep, that's part A right there. That looks to be where it's increasing to me. Okay, and what's our next question? Next part. For which time periods was it decreasing? 4 to 9 and then 13 to 16. So 4 through 9 and 13 through 15. Pardon me, not 16. And these are the gaps, right? So 1 through 4, 9 through 13. We had increasing 1 through 4 and 9 through 13. And that leaves the gaps for it to be decreasing on 4 through 9, unioned with 13 through 15. All right, so we're kind of filling in the gaps there. We're making sure there isn't an overlap between increasing and decreasing. Now, how many turning points from increasing to decreasing or from decreasing to increasing occurred? Well, it's going up, then down, so that's 1. It's going down, then up, so that's 2. And it's going up, then down, so that's 3. 3 turning points. These little, call them inflection points, where like the concavity is changing. They're not what we're looking for. These little kind of cornery resolution type things going on in the graph. We're looking for where it's going from increasing to decreasing. So that's 1, 2, 3 spots where it changes from either increasing to decreasing or decreasing to increasing. 3. Suppose that a polynomial function is used to model the data displayed by the graph. What degree of the polynomial function, what is the degree of the polynomial function of best fit? And this is based solely off of the number of turning points. We need a degree 1 higher than the number of turning points. We need a degree of 4. Should the leading coefficient of the polynomial function be positive or negative? Why? Well, I've selected negative because the terminology here is that it falls, and I've been trying to kind of avoid saying it like this, but it creates this kind of downward slope, this kind of slope. And if you imagine someone standing up here, this falls off to the left, and then it falls off if you move to the right. If you go on the left-hand side, it points down, and on the right-hand side, it points down. I think points is better than falls in terms of terminology, but I'm splitting hairs. So it's negative because the graph falls, it points downward on the left, and falls on the right. So we want a negative leading order coefficient. And then we got to estimate the person's maximum heart rate. I think it's right here, in between 70 and 80, so 75. This is certainly lower than 75, so it's at that turning point, 75 beats per minute. All right, and then after how many minutes did the maximum occur? It was at 4. If you recall that, it was after 4 minutes. Great. And now lastly, what was the minimum heart rate during this film? Let's see here. This is about 68, and this is below 65, so I'm going to call it 63. 63 beats per minute. Let's call it 63 beats per minute. All right. Great. And when did that minimum occur? Well, they gave us 15 minutes, remember, in our earlier responses, so that occurred at 15 minutes. Okay, great. That's this exercise. Thanks, and I'll see you next time.